Hello and welcome to Tech Talk Tuesday. All right, so today I'm your host Shazad Ali. I'm the Principal Solutions Architect, and joining with me Matt Kazmar. He's the Customer Solutions Architect, helping a lot of customers these days who are actually deploying their Kubernetes workload in GCP, in AWS, and Azure. So today we are going to take a deep dive into securing your Kubernetes applications in GCP with the next generation firewall. Okay, so let's move on. Now, before we dive into the topic, I just want to give you a brief overview of our platform. So Aviatrix is helping a lot of enterprise customers deploying their networks in the cloud and in multiple clouds. And if you look at this diagram here, the solution starts from this controller. So this controller is a virtual machine or EC2 instance that is available in pretty much every major CSP marketplace, and that's what you deploy first. This becomes the brain of the solution. And this is a very intelligent device which has multilingual capabilities. It can actually talk to your cloud native constructs. It knows and control your cloud native routes, your load balancer, or whatever you have there. And but not only that, as we know that the CSPs are behind in terms of providing advanced networking and security capabilities, the controller also deploys a proper cloud networking architecture with a hub and a spoke topology you see there. Okay, so these red circles or orange circles you see in the middle here is the transit gateway or a hub, and then you have spoke VPCs connected via this hub. And if you look at this diagram, we have a proper networking architecture with cloud access, cloud core, the cloud app layer, and then security and operations that are extremely important, and they cut across all these layers. On the left-hand side, you can see this controller is also talking to the third-party vendors, such as Checkpoint, Fortinet, and whatnot. And this is about providing the advanced functionalities, the next-generation firewall, the service insertion, or maybe you have a use case to insert some next important or the load balancers in your flows. Now, on the right-hand side, we have Aviatrix CoPilot. So this is providing advanced enterprise multi-cloud operations and visibility. Because if you are dealing with one cloud, or even if you are in multiple cloud, this controller and this architecture takes care of all your cloud networking needs and provide you the visibility and control that is demanded by the enterprises. Important thing to remember that this is your network. Whenever you deploy these components, they are deployed within your accounts, in your subscriptions, and in your projects. So you have complete and total control of this architecture. There are a number of challenges and problems we are solving for a lot of enterprise customers, and I'm highlighting only a few here. So as you can see, even if you are present in single cloud, there are issues with the encryption. There is a policy-based segmentation needed that is missing from the CSP. When it comes to protecting the workload going towards the internet, there is no zero trust or policy-based mechanism to do that. And then overlapping IP type issues are there as well. So these are the challenges we are solving for our customers. But today our topic is going to be the centralized next generation firewall service insertion. Because when it comes to providing security for your applications, you have to look at it from a layered approach. One size does not fit all, right? So yes, you need to use your security groups, your firewall rules, your layer 4 stateful firewalls and whatnot, but you must use the next generation firewall services and insert them in your flows to protect your crown jewel applications. Now, if you are going into multiple cloud, everything that you see on the left-hand side stays, but now the problem is magnified because you are dealing with multi-cloud. So you might have a team who learned one cloud, but now you're talking about 2 or 3 different clouds. So it's very difficult for them to understand all these concepts. So we actually abstract all this complexity away for our customers. We provide the high available solution. It's all active. When you build it, there is no single point of failure there. And then customers are using our platform for some other advanced use cases for the disaster recovery, disaster avoidance, or if you want to drive this entire network through automation, we have a Terraform provider, which you can use that will become the single entry point for your cloud or multi-cloud deployments. So when we look at the next generation firewall, and if you are about to insert it for your workflows or to protect your workload, if you are going with the native solutions, you will run into a number of challenges. And I'm highlighting only a few here. For example, this whole interaction or deployment is going to be manual. There is no policy-based control there. There is no policy-based option to insert the firewall into your flows. And if you look at the CSPs, they don't have a unified or centralized control plane that actually we provide. And when it comes to deploying these firewalls in active fashion, again, you're dealing with a lot of manual changes, manual BGP to provide the activeness. You might be dealing with ECMP in order to run the BGP. You are configuring IPsec, and we know that in cloud, the IPsec throughput is limited. And when it comes to visibility and security, again, this is where a lot of customers, they come to us and they tell us that, hey, I don't have encryption when I'm connecting these VPCs to transit there, or how do I scale out? What about my day two operations? I have to use SourceNet in order to provide the symmetry. So these are the challenges that are there with the cloud native approach. And if you look at the other cloud providers, pretty much the same story. There's a problem is there for pretty much every single cloud out there, right? So a lot of manual config you need to do, a lot of changes you need to make sure you're putting in place. If something goes wrong or firewall is down, you're going back and then changing the route and whatnot. So that is not acceptable at all. And for that reason, we have Aviatrix FireNet solution, which allows our customers to deploy these next generation firewalls in active manner in a centralized location with a zero trust policy-based service insertion. So what you basically do, you have a transit VPC here in this example, AWS example. You have the transit gateways, Aviatrix gateways. You build the proper network architecture with the hub and spoke topology, and then within the same VPC, you deploy your firewalls. Now, through the controller, you can create the policies and you can specify that my VPC here on top is my dev VPC, important VPC, and that's what I need to expect. And we will do all the route plumbing, all the route programming, all the security group, load balancer, you name it. We will take care of all those things for you. And at the end, you will have your intent realized in the network. Same thing we do for Azure and GCP, but obviously under the hood, they're different, and we know exactly what those differences are, but you don't have to worry about those. So we eliminate all the challenges and limitations that I spoke about in my previous slide. If I'm showing you one option here, but if you go deeper into the weeds, the architecture is extremely flexible, right? So now you see on the screen, we have two different transits where I'm saying that I'm using this transit for east-west traffic inspection, but I can have another transit for just to take care of my egress traffic going towards internet. And that is exactly what we see in large enterprises because they have different teams, they have different policies, they conflict with each other. So you can actually slice and dice this in different ways. Now, there are a lot of things that I have listed here. I will leave it up to you to read those when you're watching the video after the fact, but we are solving a lot of challenges. So all the traffic types, east, west, north, south, is being handled by this architecture. You are getting the maximum throughput out of this architecture with our patented high performance encryption technology there, right? There is no BGP, no source net required. It's a standard architecture that you can copy, paste, and repeat in other cloud. The model, again, are very flexible. We have the context-aware traffic engineering. There are different options to provide the policy or write the policy to have your zero trust applicable there. The whole interaction is also automated in terms of managing the life cycle of those firewalls as well. So you can directly deploy those firewalls from the controller, and we can actually program the routes, whether they are in the cloud or we are receiving them from the on-prem through BGP. We can do that automatically for you. And the last but not the least is something I mentioned before, monitoring and visibility, extremely important. You need to have tools at your disposal, like troubleshooting tools like packet capture, ping, traceroute, topology replay, you name it. So that's what we are providing to our enterprise customers. So I'm going to stop here, and then we'll ask Matt to come and discuss about these things in more details.
Thank you, Shahzad. I'll begin by pointing out what you're getting into when you only use native constructs to insert your firewalls in front of your GKE cluster. It's certainly possible to actually inspect your ingress traffic with a next generation firewall, but you're going to run into issues of scale here. What if you add more workloads, such as more services on your cluster or more clusters? Or what if the throughput requirements increase because you only have 2 NGFWs here? So how do you scale that out? There's a lot of challenges with active within cloud native constructs. So you end up having to do a lot of SNAT or other tricks to make things actually work as you scale out. And what if you add in another cloud? You're on GCP today, you bring in Azure, you bring in AWS. How do you connect your clusters between the two? And when you're actually looking at traffic between your clusters or through the firewall or what have you, how do you observe in more detail? Sure, you have the next generation firewall logs, but you don't really have anything else in terms of, for example, packet capturing and flow logs and anything else that Shahzad had previously mentioned. Now, GCP and GKE present additional challenges because they deal with load balancers a little differently than, say, Azure or AWS. AWS has the application load balancer. Azure has the application gateway and front door, and it's all sourced from within the VPC or the VNet, which makes it a very easy east-west traffic flow. So like I showed on the previous slide, it can just live in another VPC or another subnet or what have you, and just go through the firewall like any other traffic. However, GCP is a little bit different in that their external HTTPS load balancer actually has a public IP address as the source. It actually behaves a lot more like, say, a Cloudflare or an Akamai or somebody like that, a third party. It doesn't actually insert itself into your VPC. So at that point, you're required to actually land the traffic on an instance. And if you go with the way GCP does things natively, you're going to be landing that on your cluster nodes. There's no opportunity anywhere to actually insert firewalls. So to actually insert the firewalls in that design, you have to do like I had done previously and actually connect it to the firewall, and then you're on top of NAT rules and that sort of thing. Now I'd like to talk about some Ingress design patterns using Aviatrix. In this particular design, we are using the next generation firewalls within FireNet to actually get to the backend, to the backend ingress. So the way it works is that your users are on the outside and they connect to an HTTPS load balancer, the GCP one, of course, and it's recommended to use Cloud Armor in this scenario because it provides WAF functionality, DDoS functionality. And you can also, if you are using a third party, Akamai, for example, if it provides that kind of load balancing, then maybe you can forgo the external HTTPS load balancer in that case. It's certainly an option. And like I mentioned before, the load balancer actually targets the next generation firewalls. And the firewall itself is responsible for SNAT and DNAT on the traffic to make sure it arrives at the correct backend. Because remember, with GKE and really any Kubernetes, you can have multiple ingress options, you can have multiple clusters. So you have to use the firewalls to actually distribute the traffic correctly because the external load balancer only knows about the firewalls. And further on the back end, you have to actually have ingress because you can't really point directly to a service. You have to use an ingress object. So you have to deploy that ingress object. And now this option is kind of nice in that you don't have to have extra ingress VMs or extra VMs or anything like that, but you do have the administrator overhead of ingress and cluster configuration. So your devs spin up a new service in your cluster. They spin up new ingress, this and that. Now you have to actually come over and configure that on your next generation firewall. And also, everything is coming in on those firewalls, which increases the load on the firewall. You have no ability to use policies to segment, inspect certain traffic, skip certain traffic, whatever you like. So it's a simple design, but it has its limitations, certainly.
Okay, Matt, so I see a question on the QA panel there. And guys, if you have any question, you can actually post your question there. So he's asking about what kind of overhead you are talking about. You mentioned some of the points, but do you have anything else in that space?
Well, the way, yeah, I do. Well, the way GCP, the external load balancer, works is it can target either your alias IPs on the VMs, which are secondary IP ranges that you can assign to VMs within the GCP VPC, or you can target just the regular primary IPs. So either way you go, you're going to have to do some overhead work because each backend is either going to have to be assigned to an alias IP on the firewall, and they have to be different alias IPs on each firewall, or you have to use a non-standard port. Like, for example, you have ingress on port 443 internally, and the user is connecting on port 443, but obviously you can't have a zillion services listening on a firewall, passing through a firewall on port 443. So you end up having to map things as in, okay, user request example.org, it's going to get set to port 7001 and then get sent back to 443 on your ingress. Now they have example.com, maybe map that to 7002. And likewise send it to the backend. There's a lot of overhead there that you have to keep track of. It's doable, but as you scale out, it becomes a lot more complicated. Now, the packet flow for this pattern is very straightforward. It just comes in via the load balancer, and it goes to the next generation firewalls, through the transit, through to the spoke gateways, and then to the ingress, and then to the cluster. So very straightforward path through. Moving on to pattern 2. This is where we actually use ingress VMs to connect to the spoke gateways. And then that appears as east-west traffic going back to the ingress if needed, and then finally onto the cluster. And again, like the previous pattern, using something like Cloud Armor is recommended in front unless you have a third-party DDoS WAF solution. And similarly, the external load balancer targets the ingress VMs. And these VMs have to either NAT or proxy the traffic. And now these can be, if you're using NAT, you could actually use something simple like Vios, which is a third-party Linux-based distro that kind of simulates a Juniper command line. Or you could even, if you really wanted to, outside of FireNet, put in another set of next-generation firewalls if you wanted to use a different vendor or you wanted to do something different. There, it gives you a lot of options. Or if you're doing a proxy, you could do something as simple as an Nginx VM or something like a Citrix application delivery controller or anything like that. And now the advantage of the last one I mentioned, the Citrix ADC F5 has something similar. A lot of these bigger vendors actually have their own ingress controller. So in this case, you can actually skip the GKE ingress because the traffic will go directly to the cluster. It doesn't need to actually use an ingress on the cluster because the VMs are actually serving as their own ingress.
Okay, so that's an important point. I see one question on this topic here. Someone is asking that how can session affinity be maintained where sticky sessions are required?
Sticky sessions are the responsibility of the external load balancing solution, because once they hit the Ingress VM, they're either proxied or NATed. So regardless, the traffic is going to be sourced from within the VPC, the Ingress VPC. So we're always going to land on the correct WAF or the correct NAT device or what have you. So it ends up being the responsibility of the external controller to consistently deliver it to the correct Ingress VM.
Okay, got it.
Now I want to discuss the Ingress design patterns from your on-prem data center, because security is still important for your coming in from your on-prem data center. It doesn't mean you can necessarily trust your users or trust different applications running. The first pattern here, which is actually pattern 3 for simplicity, is that you're using the native GKE Ingress or a Ingress installed on the cluster. The flow is very straightforward here. You just go from your on-prem here through your, in this case, it's a cloud interconnect, and then you attach directly to the transit gateways. Traffic is looped through the next generation firewall for inspection, and then it is sent over from the transit gateway to the spoke gateway, and then onto your Ingress, and then to the cluster.
So one question I have, Matt, here is, does this pattern or solution support WAF for internal users?
Using the GKE Ingress, it does not, because GKE Ingress, unless you're using Cloud Armor, it's not supported. So you'd have to use a third-party Ingress. Nginx has, for example, it can do the OWASP inspection, and that's natively supported within Kubernetes in general. So if you target that kind of Ingress, then absolutely yes.
Okay, sounds good.
Moving on to pattern 4 here, this is using the Ingress VMs that we would have deployed in pattern 2. And you may want to do this just because your Ingress VMs may have their own WAF on them, or you prefer to centralize all your Ingress into the cluster, not just have it distributed depending on where it's coming from. So the flow looks just like this. Your users will connect, it'll go through the transit gateways and then loop through the firewalls and then go up to the spoke gateway. And then if needed, you'd have to deploy an ILB in front of your Ingress VMs. That way the traffic can actually be distributed to the Ingress VMs. And then once the traffic is on the Ingress VMs, it's just like the internet flow pattern, where the traffic leaves the Ingress VMs, it goes to the spoke gateways, transit gateways, the firewalls, spoke gateways, again in the GKE cluster, or in the GKE VPC rather, and then onto the GKE cluster.
Okay, so this is interesting because it looks a bit complicated than the previous design. And if I'm not wrong, there is a double inspection happening through the firewalls.
That is actually customizable. You can opt to exempt certain traffic from inspection. So in this pattern, you'd end up removing the Ingress VPC from the firewall inspection, because the GKE VPC will remain in inspection. So that way your users will it'll contact the Ingress and the cluster, but they'll be sent directly to the Ingress VMs via the transit, bypassing the firewalls. But then when the Ingress VMs open up their connection, those will be inspected by the firewalls. The green line there, it'll actually go back through the firewalls and you'll have full inspection. You just won't have that double inspection, double overhead that you'd otherwise have if you just turned on inspection as a blanket policy.
Okay, so that is good, actually good to know, because that actually gives you the flexibility, even though it looks complicated than the previous design where the traffic was coming in from the on-prem, going into the centralized firewall through our transit gateway, and then was reaching to the GKE VPC. But here, obviously, if a customer is looking for something special to do in the Ingress VPC, he can actually get best of the both worlds.
Yep, exactly. Now I'd like to talk about the egress design pattern. This is a very straightforward design because really all you're doing is the GKE cluster and the pods they're on are very similar to any other workload you'd have in FireNet. So the pods or the nodes or what have you would reach out, talk to the internet. They'll have a default route on their routing table, which is going to this spoke gateway, and then it's going to the transit gateway, and then it'll hit the next generation firewall and go on out. And that way you can keep your central egress. You get all the logging and all the goodness of the firewalls. You get to see what's actually happening en route on the spoke and transit gateways. So all in all, it's a great routing solution. The only thing with GKE that you have to be cognizant of, and this really would apply to any provider depending on how they do their networking, GKE nodes will do secondary alias ranges with the VPC pattern that they have, and those will be assigned to the nodes. Now, if the pods reach out, they'll be reaching out directly with their IPs, and that may or may not be part of the spoke gateways routing table, depending on how you have it configured. So you have to think about either using IP masquerade on the cluster, or you have to think about adding those secondary ranges to the spoke gateways. I lean towards the first option just because most of the time the pods don't need connectivity directly with their IPs, and IP ranges are scarce, especially when you get into pods. So it's usually much better just to do the IP masquerade functionality, so that way the traffic is sourced from the node IPs instead. Now moving on to a real world example. I've actually deployed this and it all works fantastic. I can see all the logs and everything. So next slide here. In this example, I have using the F5s as the Ingress VMs, just because they have a nice feature where the actual Ingress controller on the cluster can orchestrate the configuration on the F5. So it makes it very straightforward, as you can see on the right-hand side, for your devs to actually expose the service. Now the flow is like the others with the Pattren 2, where it comes in via the HTTPS load balancer, it hits the F5, hits the spoke gateway, transit gateways, and can be inspected on the firewall before being sent over to the spoke with the cluster in it.
Yeah, that's actually really interesting because now we have deployed this with some external load balancer, and then Ingress VPC has this F5 load balancer in this example. Obviously, you can use any load balancer there, but this F5 also has a built-in WAF functionality, if I'm not wrong. And I just wanted to know, do I need to use this HTTPS still?
You don't actually. You could actually use the network load balancer if you wanted to. But the critical piece here that the HTTPS load balancer provides that the NLB does not provide is Cloud Armor. And even if you don't use Cloud Armor's WAF, you want DDoS protection, because I don't care how big your Ingress VMs are, if you get a sizable sustained DDoS attack, they're going to be overwhelmed and you'll have an outage. So if you opt to use the NLB, the recommendation is to have an external DDoS service that you can use. And that at least you're mitigating your DDoS situation. Then you can use the F5 for WAF or whatever you have as your WAF solution.
Okay, got it. Yeah, that's a good point.
So moving on to one of our crown jewels here, we have the Aviatrix CoPilot. And what this does for you is it allows you to actually call up records from each of the individual gateways and really see what's going on your network. And these records, the hosts here listed are actually the spoke and the transit gateways. So when I was testing my solution, you can actually see from the source CIDR, which is the 172.12.1.12, that's the F5's IP, going to the back end, which is the 172.22.0.30, which is one of the node IPs in the GKE cluster. You can actually see, what time, what kind of throughput you're getting, how many packets were sent. and pretty much anything you want to know about what's going on in your network. And you just don't get that level of detail if you're looking at flow logs or any of the native constructs on really any of the cloud providers.
Yeah, so this is very powerful because, like you said, you're getting deep visibility, deep analysis into this your flows there. So what about some visualization technique? Because I see you have the topology and other options on the left-hand side. I know we cannot cover all of them here in this session. We have YouTube videos recorded on our Aviatrix channel, but can you speak about those things for security compliance or for audit needs?
Yeah, absolutely. Topology is actually a fun one because you can actually go and look at the topology of how how your network works actually in a visual way. And in addition to that, you can actually do a replay. So you can visualize what's actually changed in your network over a given time period. So if routes have been added, routes have been removed, gateways go up, down, tunnels go up, down, you can see all of that. And then if you want to look at, for example, your VPCs, you can see which VPCs are managed by Aviatrix, which are not, and you get an overall picture what's actually there in your environment. So if somebody's spun up a VPC that shouldn't be there or you don't know about as an administrator, then you can actually look at it and be like, okay, what is this? Let's go find out. And that helps you a lot when it comes time for your audits, because really what's an audit? They're asking you, how well do you know your network? How secure is your network? What are your, how can you get information if there's a situation? And CoPilot really provides all of this for you.
Perfect.
And of course, since we have a next generation firewall here, we have the ability to view logs on here and see what actually happened. So depending on what your firewall vendor of choice is, you can see if something was dropped. You can see, okay, was it dropped because of a virus detected, some sort of payload issue, anything like that. Of course, in these logs, everything is fine and it just kind of sailed on through. But still, it's another source of visualization for you, and really another way to see what's going on in your network.
Right. So I see a question here on a QA panel. Why do you have these service on a high number TCP port?
That's a good question. The way F5 does their Ingress design is they have you expose your services on the cluster, and this really is for any cluster. They'll have you expose it as a node port. And what a node port is that your service is mapped to a high port between, I believe it's 30,000 and 32,767, but don't quote me on that. And what they do is you map each service to a port in that range. They pick a random port, or you can specify. So the way the F5 does it is the F5 is doing your ingress. So it load balances, it does all that sort of thing to your pods. So when it receives a request, it'll actually forward the request to the node port that I mentioned. So that's why in your firewall logs, you're going to end up seeing these high numbered ports for all your node ports. Of course, if you pick a different solution, such as like a GKE native ingress-based solution where you're doing NATing, then the port will probably be more standardized, like a 443 or a port 80.
Okay, got it. Thanks, Matt.
And finally, we're going to go into these two supported multi-cloud design patterns with Kubernetes, kind of highlight what Aviatrix can do for you to solve some of these different architectural challenges. And now the first one here is you have your dedicated ingress for each cloud. Everything is kind of separated. You have your AWS is on one side, GCP is on your other side. And now what Aviatrix does for you is it provides this connectivity. So you have a cluster workload in GCP, right? And it needs to talk to the VPC, the cluster workload in the EKS VPC on the AWS side. You can do that. The routing is all there. You turn up that transit peering, and all of a sudden, all of these guys can talk to each other, pending, of course, firewall rules and any other kind of segmentation. Or maybe you have a workload, like an actual just a server sitting in AWS, or it could be Azure, it could be OCI. Now you want to talk to your GKE cluster. And again, that's totally fine because you have that connectivity. And have to reemphasize that all this connectivity is encrypted between your various gateways. So it's not like it's ever going to go over the internet or over, between cloud providers or anything like that in a visible form. Another design pattern that's actually supported and is kind of nice here is that you can do segmentation. What I was talking about previously is that you can actually segment out this workloads. One, you could do it with your firewalls, the next generation firewalls, obviously with IP ranges and stuff like that. But also Aviatrix supports segmentation natively. So let's say you have your GKE, your EKS, and your AKS workloads here. Let's say the blue ones are dev and the green ones are prod. If you do the segmentation, you can ensure that only dev can talk to dev. So only the blue clusters talk to the blue clusters, and then only prod can talk to prod. The greens talk to greens. And this is a nice way of keeping everything separated so you don't have anything jumping between dev and prod, and your developers can be assured that they're not going to mess anything up in prod, and they just aren't able to. This final design here that I like is it lets you do an add-on. So let's say you're a big, AWS customer. You have various workloads, various servers. You have your direct connect to your on-prem location. Everything's in AWS. But you take a look at GKE and you think to yourself, yeah, this is fantastic. I like these features. I want to use GKE to augment my AWS infrastructure that I have right now, but I'm not really ready, to make a full commit to GCP. I just want to use GKE here, right? So what you can actually do, our transits and spokes, they'll talk to anybody, any spoke will talk to any transit. So it doesn't really matter if the spoke is in GCP or AWS. You can still connect your spoke directly to transit and take advantage of FireNet and whatnot. So it's a very nice way for you just to add on GKE or really any cloud, because you can start small, and then when you're ready, you can go to one of the other designs where you have full transit in, for example, GCP. But you don't have to do that right away. You can just kind of do what you do.
Yeah, I mean, that's really powerful. Like you said, if you are in a situation where you need to quickly spin up spoke gateways, have your GKE cluster connected to AWS, and then later you can easily grow and migrate into proper dedicated transit and base architecture per cloud. So what I'm hearing is that this AWS Ingress VM can be used with the GKE cluster. Is it true, Mark?
Yeah, that's absolutely true. This design supports that. I did actually, just for the fun of it, I did try to connect the ALB to the GKE cluster, but that doesn't work due to AWS AIM or IAM roles. However, if you use something like the F5 or the Citrix, will work. If you use like Nginx as a regular proxy or something like Vios to NAT, those absolutely do work because they don't, they're agnostic. They don't care. As long as they can talk to that cluster, they're going to work for you. So, you really can just focus on your cluster and just leave the ingress as you have it if you already have a secure setup for your existing ingress.
Got it. Okay. Very good. Very good. So one thing I would like to add here is that these are the popular designs that we see out there, but this is not it. If you have a specific design that you want to discuss with us, we can definitely talk to you, and based on the requirement, we might come up with a different design, because like I said, there are unique customer requirement, enterprise requirement, and we can actually satisfy pretty much all of them.
Yep, just about anything you could imagine, we can connect it in the cloud, how you like it. All right, that's the end of the main presentation. Shahzad, do we have any questions from the chat?